Good morning. This is Dr. G.Sreenivasa, Associate Professor of Triple Department in Jipulad Engineering College. Today we are going to discuss about the smart grid. See, first of all, what do you mean by grid? Then we go for the smart grid. So, grid is nothing but interconnection of different generating stations or different substations. Simply, you can call it as a grid is nothing but it's a substation. Okay, so there we have the different interconnection lines from generating stations or from the substation to the substations. So overall, we have the interconnection transmission lines, right? So with the operating voltages of different voltage levels, right? So this is about the grid. Where in the smart grid, and nowadays each and every person have very, comfortable with the smart operations. So even in the grid operation also, with a, advanced infrastructure with an advanced metering structures, so we are minimizing the functions and we are reducing the, manpower, so that everything we are going to make with the smart devices. So that all these operations in a substation, all the operations in the grid are operating with a smart. So that's why we can call or we termed as a smart grid. Coming to this smart grid, a small introduction. So first, what is smart grid? See, it is a power system architecture that permits two-way communication. So that permits two-way communication. See, as of now, we have only one-way communication right from generating station to load centers. So in a long process, right from generating station where we are going to generate the electrical power, and then it is stepped up, and then transmitting, then uh, distributing, and then finally we are utilizing successfully at the load centers. That is completely one way. But now even the consumers will become the generators. Some of the consumers, some of the loads are generating its own electrical power. So if that generation is more than the load requirement, sometimes then definitely the excessive power is need to send back to the grid. So that is the second way of communication, so that we can call it as a two-way communication system. So this smart grid incorporates smart grids enables the two-way communication system. So that's why I mentioned between the grid with the all devices which are connected to the system. Okay, so in smart grid model, traditional generation still major role. Of course, without generation, there is no possibility of running of the loads. So traditional power generation still having the major role, but it is augmented by the distributed generation system. As of now, we have the distributed. So as soon as the smart grid operation will comes into the picture, it is just because of the distributed generation system. So each and everywhere we are going to generate the electrical power, it is distributed in micro levels. That's why the distributed generation system is an important role in present scenario of a grid. So that is in the form of, different small generating and scalability generation systems like wind, solar, and other owned power generation systems. And economics of cost saving from the peak load reduction. See, especially as of now, the tariff rates, each and everyone, we know that different tariff rates based on the different timings. So we need to minimize the peak rate tariff. So this type of DG systems will help to us for the minimizing of monthly tariff. And next, it reduces the operational maintenance cost. See, as we know that we are generating the electrical power where the favorable places, which are located far away from the consumer premises. So we require to transmit and we require to distribute over 100 kilometers of length, right? But if we are going to generate where we required or where we need to run the loads, so there itself, if we can generate the electrical power, then definitely we are going to minimize all these losses, transmission and distribution losses, so that it will indicates indirectly minimization of per unit cost. Okay, so technically we are going to minimize the losses. Indirectly, it shows that it represents the minimization of per unit cost to the consumers. So it reduction of operational and maintenance cost. At the same time, it improved reliability. Why? Because all the technical parameters which are involving in transmission distribution system, so almost all are minimized so that technically the system it will be suitable and it is very reliable to the consumers for continuous supply, for uninterrupted supply, for minimum cost operation. Okay. And next one is it reduce the industrial consumer cost services and it improves the reliability and power quality reductions and efficient power delivery. So at present, transmission and distribution companies are giving supply to the consumers, but it should be having some conditions. Definitely, we need to maintain the standards. Okay, so if it is for a single phase AC supply, definitely we have to give the supply with a quality. The quality means voltage, power, frequency. All these are we need to maintain. Okay, so all these parameters we are going to improve. So that is the efficient power delivery to the consumers and improved grid security. The security of the system will increases as the number of parameters will involvement will be reduces. That's the main reason. And at least the contribution of environmental impact reduction in the carbon and CO2 emissions and then greenhouse gases. Why? Because we are minimizing the existing resources so that we are improving or adding of non-conventional so that all these environmental aspects and greenhouse gases and some harmful gases we are going to minimize and increasing the penetration of clean energy. See, as we know that all these non-conventional maximum percentage of non-conventional sources are of, clean and green energy resources. So that where our contribution to the society is to minimize the penetration of clean energy, increasing of green energy and minimizing of existing resources who are harmful to the society. Next, coming to the evolution of a grid, how the electrical grid it will be in previous how it is and as of now how it is in olden days. So what is the operating voltages and year by year how the voltage levels has been increasing and it becomes a grid. And Indian point of view, Indian scenario point of view, we have the different grids in different regions, southern, northern, and different regions. We have the different grids. Even in the state wise it come across as it we consider as a one grid. The complete state has an individual grid, and such an electrical grids are interconnected to that regional states. That region we can call it as a regional grids. Such and regional grids are interconnected to the other regions. Likewise, southern to northern, northern to eastern, complete central to other regions. So year by year, the growth has been increases, and how it is we will see. See this evolution of Indian national grid, how it is. See in history of smart grid, we can see that in pictorial representation. In October 1991, northeastern and eastern grids were interconnected, whereas in the March 2003, western region and east region and northeast regions were interconnected. And then in August of 2006, the central grid operating at one frequency at last in 31st December in 2013. So we are achieved the one nation, one grid and one frequency caption. And now we are planning to make it that one nation, one grid and one frequency operation with an one price. See, throughout the nation, the price of the per unit cost of the electrical power, it should be the same. Okay, so different resources we are using, different states we are using with that with their circumference and with their conditions. The tariff rate has been different based on that. Different aspects, individual state electricity boards. But now. It is going to be a one nation, one grid with one frequency along with the one price, right? So this is about the introduction of the smart grid. And next session we are going to discuss about the brief in smart grid. So please stay with me. Thank you.